Hello and welcome. Continue our journey of implementing the DBML parser in C++. Let's get into this DBML thing. So this is the syntax, and also let's get into the playground. Oh, what is this? Oh, they added something. Record. It seems like just the entries into the tables somehow. So from this, if you export, I guess, then you would get values also inserted, not only just tables created. Let's see if there is anything in syntax. It is records. A data sample. Okay. Interesting, but for now we won't implement it. I don't have plans. Like if we would even implement it at some point, that would be like the last step, because we have still a lot of things to implement even without it. So to recap what we made last time, we managed to parse enums and we managed to parse tables, but partially. So we parse the table as it is, for example, like here or like here, and we parse the columns only with settings. But I said, I accidentally closed. I we parse settings, but not all of them actually. I said we parse all of them, but I was just a bit confused, and I forgot. If you go into column definition, column settings, there's a list of those, and I used it to implement all of the settings listed here, but I forgot that there is one extra thing at least, that is relationship, but it was mentioned like in a separate chapter here. That's why I forgot about it. And we would need to implement this for tables. We would need to implement table aliases. We would need to implement checks like this and indexes. I presume the indexes would be the hardest because they have a lot of things here. But we'll see, because there is like those, well, like one column or a list of columns, then some settings for them. We'll see. We'll see what settings those might be. Yeah. Okay. Let's get into our code and see what we have. Yeah, we have this, and we can parse this at the moment. We can parse like multiple checks and all of those things. Yeah, but the one thing I would like to actually add is, if we go, for example, into Parser, there are a lot of places where I do this errors thing, and I would like to make some method for it, like fatal or something. Let's do it like, I don't know whether to do it inside or outside. Maybe. For now, let's do it inside. So we would have void the fatal something, and here we would write some error and then exit. So we might need the error code, and I really need to check. So C++ exit, what type it is, what it expects. It expects an integer. So it would be exit code. I would exit with it, but before it, I would like to just as it's error and write some error message. But before it, to write this color code. So this is red. Then write some message, and then write. So let's now do even like string message, and then do the reset of color like this. Yes, and but I would like to use it as printf, for example. And for that, we might want to use format maybe. Where is this thing? It will have a little bit different syntax as printf. But that's okay. So how we do it? Like what? Have to add some template. This. Or no, or it's like this. And it would be not, it would be something like, we have to include it as well. So format, right? Right. This is format. Now we want some kind of this std format string args, and it would be format and args, and we need to just somehow do, and I don't know how to unpack args actually. Like, should I do like this? Let's see if it even compiles. So I need to again my alias. This is make build and build DBML parser. Yeah, it does. Okay. But I see that it's this signature. So we might need to forward it. Like, but I don't know how to do it. So std forward. Is it like this? Yeah. Let's now then try to use it somewhere. For example, here. So you would say it just fatal and unknown entity placeholder, and this word and we can just comment it. Oh, and see if it works at all. No. Oh, I forgot the error code. Right. I forgot the error code, and here we everywhere return the code to. So, okay. How should I do it? C++. Hmm. Let's compare. So type name args. Now format string args and args. Right. This is customs formatters. Plus take forward to be format. Oh, okay. So we have to specify this. But okay, yeah, this one. Okay, let's see. Yeah, cool. Let's then try to add some. Let's try to add some different thing like ref. I don't know. And it says, yeah, some unknown entity ref. Cool. So this thing works. Let's then try to replace it everywhere, the usage of it. Let's see. We can delete this, and what we do, we would just go like this. And instead we would do fatal and expected any string after node. Oh, so we don't even have any arguments here. Cool. Yeah. And then we can delete those. And I, for some reason, written even to see out. Okay. I probably have to search for exit instead. Yes. And here we do fatal expected key after primary, also without any arguments. Let's go next, and here we do also fatal expected null after not. Yes. Now, oh, here we finally have some parameters. So fatal invalid default value and placeholder, and pass this thing, and yes, here also invalid default value. Let me then just cut it from here. Yep. And I just need those things, and yes, valid value, and we don't have any argument here. And now we have invalid setting, fatal so if it's end line, have to check if we even have anything. So peak, if it has peak value type or end of, and we have to do to string, for example. Have to wrap it into a string. Yes, and also this, and we can delete it. Oh, here we have some error as well. So fatal expected one thing, got another, and here we do a string type, and I would just do this. Yes. And let's see if we got any exits only here. And anywhere else? Oh yeah, we got here. You got here. This is for consume project and the settings. Not settings, but properties. So database type node, and also we just say fatal expected project property, and it is keyword. And here is what? What is this? Yes. So if it's not a property but something else, we say for now just like invalid project definition. And I everywhere forgot the exit code, right? And it is, exit code is 2. But you know what? Maybe we would really then just, how to do it? For now, we would remove this error code here and set it to like constant 2. So we would here do, oh, oops, this 2. And instead, we might want to define this fatal somewhere like outside. But here we would just use it then. There would be also this fatal method here, but maybe like in parser we would have some like positions and extra things to it, where it happened. So yeah, maybe. For now, let's just hard code it. And now let me check where I have something like this. Yes, I have to remove this too. And never else, because everywhere I use just fatal and message. Okay, let's see. There is some warning. What does it mean? Control reaches end of not void function. Hmm. Oh, no. This, I thought like I forgot to supply the parameter, but no. This is weird. I don't know what does it mean. Should I somehow modify the fatal? But I don't think so. Let me then, I don't know. Oh, okay. No return. Let me check. C++. No. What does it mean? Hmm. Okay. Okay. Let's then go here and where we do it. Like, is it correct? No. Should I move it? Oh, no. Yeah. Yeah, and the warning is gone. Cool. Yeah, nice. So we got ourselves this fatal thing, a bit of convenience to make it easier to throw those errors. Let's then try to implement other things, continue our parser. So what we need is we go to the table and we need the alias for it. So like the possible alias for it. So we have the table name and we would then add this optional string view table alias. Let's see how it is. So we have this as and you. So how we check it? And this alias could be, we'll see for now. What it could be, alias as, and this is valid, this is not, this is valid, this is not. So it's again a word or quoted thing. Let's see. We might have something like this already somewhere. Consume name. Yeah, here it is. Consume name. Okay, we have to then somehow just check like this. Look here that it is. So we say if peak and if peak is token type word and peak value is as, then we consume it and say table alias is consume name, and we have to also print it. So where it is, table name, and here we would have to do it. So for now we would stop and do this and say if alias, then we also output it. We do as and table alias. Yes. No. Let's see. Alias is optional. All right, we use optional value then. So again, this is consume table, and here we just have to do for this here. We do value. Try again. Does it return? Okay, let's see. Maybe this consume name, and how do I search for the definition? Oh, consume name. Consume name. It returns token. Okay. So let's then go here, and this should be value of it. Right. Token value. Yes, really good. Yep, cool. And now let's just edit then this file, remove this thing, and add some alias to a table. So we say as f, run again. Yeah, cool. So we've covered the alias here, and then just try to add some like alias different one as like this. And here let's try to add something not correct. Yeah, so this is L, this is this thing, and here we got error. Perfect. Good, 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 good. Now what we do, maybe, you know what, just maybe let's edit this to remove this invalid case. But then let's edit the parser. I thought maybe we could add some prefix here, like error, and like this. So it's not just the red thing, but you would also have this error prefix. Cool, so we've covered the alias. Now we might move further. Let's see, maybe the easiest one would be to add checks to the whole table at the moment, because the checks are just an expression and possibly a name as a setting, but no other settings are possible, not even a node, right? So if we got, let's try it, if we got some, is it checks, right? Checks, and here we got something like here, and now name. Yes. Could we get node? No. Check doesn't have node. Cool. Cool. So let's try to implement it. It looks really easy, actually. Let's go into our consume table, and here so we consume the columns. But the thing is, it's either a column or this checks definition. It might be actually harder. Can we, by the way, have it somewhere like here? Yeah, this is perfectly fine. So I guess what we would do is we would check the first token here. If we see that it is checks, we would do something. If we see indexes, if it's indexes, we would do something. If it's a node, we would do something with it. Otherwise, we would just try to parse it as a column. And yes, checks, indexes. There might be, could be relationships defined inside the table. No. Seems like not. I hope so. They are defined outside. Yes, cool. Cool. Then it's good. Then I guess we can proceed with this plan and do inside here. So we surely know the peak, we have something, yeah, because we do this peak. So we say if peak is like this, and peak value is if it's what checks, then we would do something, and we would have this else, and we would have yes. Or oh, this is printing. Oh. Or not. No, everything was good. Okay, okay, because we just print and parse at the same time. Not the best strategy probably here. Anyways, if we see checks, then we do what? And maybe we would have a separate function for them. This is consume column. Let's then have void consume checks, and so we consume once because we consume this this word, and now we expect so we say consume curly open, and then while peak and how we do it, not peak is token type curly close. We consume those checks, and let's then have some collection for them. So this is vector, and it would probably be, I don't want to define type for this yet, but I really should. But for now, let's do, and yeah, it's std. Let's do like let's do how this done using check is this pair of this is the expression, and optional name. And now we say vector of checks, and here we do, so we consume the expression. So we say yes, and we check for the settings. So if peak is bracket open, then we consume at the end. What we do, we now consume if not big is, if it's not a word, we would just fatal. If it's not a word, or pick value is not a name, we say fatal. Invalid check setting. For now we'll do without arguments. Maybe we'll add them later, because we'd have to check for those and the file and things if we're outside, if we're not. So instead here we consume it. We consume colon, and now we consume any string. So we would say yes, and we say this check name is consume any string. Is it correct or not, or is it just a name? So checks like this, and now name correct, incorrect. So it might be it must be a string. Could it be a multi-line? Yes, it could be a multi-line. So we consume any string. Everything is correct. Consume any string. And we then consume token type, bracket close. Yes, and we just append checks push back make pair this what is it, expression check name. For now we will just print them. So what we do checks. Oh yes, and now for we can even back it const auto expression name and checks. We do spaces and then expression, and I remembered we have to do value because it returns a token. Now we did this, and if name, then we do name yes, and this is it. We've printed them, and we just need to now print this thing. So here we would say Yeah, consume checks. Let's see if it even works. No, of course it doesn't. So name is, oh, we need to do the value. Consume checks, or let's search for, what is it? Check name. And here we need to do value. Okay, and consume any string. Oh, this should be a call. Okay. No. So let's go. Where is it? Table. So here, if it should be the call, because yeah, it's a function. And the other thing was consume any string was not declared. Really? Isn't there like consume? Oh, we have pick any string probably. Let's see. Consume name, consume entity. Pick is any string. Yeah. Okay. Okay, so when do I use it? Consume any string. Okay, we should then replace it. So if not pick is any string, then we say fatal expected a string. Yes, and here we just say consume and how we do it. Does we consume I would not be able to find it. Yeah, consume doesn't return anything. So we have to do peak value and then just consume. So this is peak value, and here just consume it. Oh, and I forgot to call it. Okay. There it is. Okay, what's wrong then here? Oh, it's peak is token. Okay. So that is it. Cool. All right, let's then add those checks. So we have this table, and let's add it somewhere in between to test it. We have checks, and maybe even something like this. Checks, and here we have some expression, and here we have as well some expression and then name. Let's see if correct thing works. So the checks. Maybe I forgot to consume something some curly, whatever. Oh, no, not this. Give me my parser. Consume checks. Yes. So consume token time curly. It's curly close. Yes, cool. So you see, it works, but we have to indent it. Yeah, we have to indent it for sure. But apart from this, it works. Let's then just indent it. Consume checks. Let's see. We have to actually indent everything here. Here we do more. And here we do, yes, like this. Let's see. Yes, good. Perfect. Just like we would want them. What we might do next is, what else we need to parse? So we've got checks, we need index, and we need the refs in the column. And in index we have a lot of different things. In the ref we have the type, so ref type, and then what entity. Okay. So still we don't support any schemas, so we would just have table name and column name. Type might be one of those. Or the type is actually, so we have this actually defined as tokens. It's left, right, this is left, right, and this is just a dash or minus, I don't remember really. Okay, maybe we would then for now implement this and then move to indexes. Let's see. Where we do it in consume column. Here we are. And this is settings. And we check the keyword. We would do it probably here, say else if k is ref, and we consume ref. So we consume, or yeah, it's already consumed, right? Right. So we consume token type column. Then we have to consume one of those types of refs. Is it possible to have ref users user name, but yes, so all four are available. Okay, so we have now to check if it's left, right, or dash. I don't really know how at this moment to represent the relationship. Type. Let's do it for now, just consume it. So we consume the column, now we consume one of those. So we say it should be a word. So value if it's left, or oh no, it's not a word. Oh, it's not a word. We have to get through tokens. Not big. We'll just say oh for now what I did. Yeah, here. We would not do this. Instead, we would do if peak is token type left, and here we would do if peak is token type right with one offset, and we would say something, and for now I would have like string rel type, then is this. Now else rel type is left. Here else if peak is right, then rel type is this. If it's, I don't remember what is it dash or is it minus? Let me guess, it's dash. Then it's this. Else we say fatal, expected, or let's say invalid relationship type. And now we need the column name, so we say consume entity name. Or we consume for now like the table name and the column name. So we say auto table name is, oh, we do consume first of all, consume, and now our table name is consume, or no, consume name, and do we have like a value to it? Or we have, yeah, we have this consume dot and let's say ref table name or ref column name is consume name value, and we need also have some vector for them. So this is checks. We would have a vector, and we need some sort of ref is, where this tuple is. Is it in utility? No, it's in tuple. Okay. Have to include it. And is there like a name go to previous position, previous location? Oh yeah, Control O. Cool. So this is tuple of string, and then table name, and column name. Refs. Now here we say push back, and is there something? Make tuple? Yeah, there is something like make tuple. Make tuple, and we say type. Table name, ref column name. Yes, and we have to print it as well. And we would do it probably at the end as well. Yeah, before not. If not, we don't even need this if. We can just say for const auto ref in refs. We do and we can even deconstruct it into rel type, ref table name, ref column name, and do ref rel type rel table name dot ref column name. Yes, and if we can even merge it, we say If it's still greater than 0, we print the comma. Yeah, of course we got errors. Oh. Okay. I forgot this one. Rel type. And it is std string. And in consume column 291. Else if else. What's wrong? Oh, yeah, I forgot. This thing. Yes, then let's try to add those checks. No, not the checks, but the refs. Somewhere here, so it is to users ID. I don't know. Oh, yeah. Really, I really didn't saw like what is it. I just picked a random table, random column, and it appeared to be really user ID. Okay, that's cool. Let's see, and yeah, we got this ref here. Let's now test if we have like this. So we didn't. Let's see why. So let's go here. So if it's a left, then if it's a right, we have to probably consume one extra. Yep, cool. So we implemented the relationships inside the table. Now what else might like to do is those indexes. Have those indexes, but there's a lot of settings for them, a lot of stuff. Okay, and there is like single column, multiple columns, expression. Oh, okay, so you might have just a column or expression, but this expression should be in parens. Let's see, indexes. ID. No, it's not required. The parents are optional actually, but they are required for multiple. And then the settings and nothing else. And the settings are name, node, type, and unique and primary key. Okay. Yeah, it's interesting that they didn't mention the node, but use it here. Okay, okay. Seems not too hard. But we might try to do it. We might try to do it in the next episode because we already covered a lot of things here and it's pretty long. So for today we've implemented checks. We've added the alias to table, implemented checks in the table, and we implemented the inline references for the columns. Next, we would probably like to cover indexes and relationships. Not those, but like those syntaxes. Short form, inline form, yeah, long form, short form, those two, because this we already cover, but those two. Yes. But before all of those, we might actually start finally defining the structures, the classes or structs for those entities. Because for now we just print them, we know where to store them. And instead I would like to really create finally those structures and return them finally. So yeah, this is it for today. Like, subscribe, share, you know what to do. Have a good time and see you in the next one.